Algebra review, rational expressions. To begin with, we're going to define rational expressions, of course, so we can know what we're talking about at all. We'll move on to simplifying, multiplying and dividing, and adding and subtracting. Okay, so to define a rational expression, the idea of a rational expression begins with a fraction. If x and y are real numbers, then the quotient, x over y, often you'll see that as x over y, where y is not 0 is a fraction. Okay, nothing crazy there, stuff we've seen before. The number x is called our numerator. The number y is called our denominator. Now, what happens is that we are going to put some variables inside our fractions. Okay, so algebraic fractions are quotients of algebraic expressions. So if they're polynomials, that's where we get this idea of a rational expression. And a rational expression is a ratio. A ratio of two polynomials. That's what we're looking at. So some properties of fractions are two fractions are equal. Again, denominators are not 0, but they're equal if and only if b times c and a times d are the same. So we can cross multiply to tell if they're equal. Okay, that's useful when we go to solve these. And then, of course, the fundamental property of fractions says, if you notice, we can cancel, if we have something on the top and the bottom, we can cancel those two out. So if we were to cancel our bad choice of shape to draw there. So if I take my red here, I can cancel those two, and that works out just fine. Also, we've got these ideas that if you multiply fractions, you multiply across. And to divide, we will flip the second, keep the first, change to multiplication, flip the second, and then multiply. So we flip that one over, a times d, b times c. Addition, subtraction, if you have the same denominator, you can keep the denominator and add the numerators. Same thing with the numerators in subtraction. And of course, pause this at any time if you need to write some of this down. Okay? It's a great idea about a video. So in mathematics, a rational expression is a ratio of two polynomials. Okay, so a good example right here, we have x squared plus 5, that's our numerator, and x plus 2 for our denominator. As long as the denominator is not 0, and that becomes pretty important. Okay, we cannot divide by 0. Okay, so let's evaluate one of these. To evaluate a rational expression, for a particular value, substitute the replacement value into the expression and simplify. Alright, so if I take this value of y equals negative 2, in this expression, y minus 2 over negative 5 plus y, everywhere I see a y, I'm going to put in a negative 2. Alright, so let's put in negative 2. So our numerator is negative 4, and our denominator is a negative 7. Okay, so simplifying that, we get a positive 4 over 7. And that works great for almost every number. But what would happen if we tried to evaluate for y equals 5? Well, let's do that. We have 5 minus 2 over negative 5 plus 5. So that would be 3 over 0. Because we cannot divide by 0, this is undefined. Undefined. We cannot do it. Your paper might burst into flames. Okay, so we have to be able to determine when a rational expression is undefined. Okay? It's undefined when our denominator, the bottom part of your fraction, is equal to 0. Numerator being equal to 0 is okay. The top can be 0, but the bottom cannot. We cannot divide by 0. Okay, let's look at a little bit of simplifying rational expressions. So we said earlier that a fraction, if you have the same thing on top and bottom, a factor that's the same on the top and bottom, we can cancel those out. Okay, so this example right here. So a times c, b times c. We can cancel out our c's to get a over b, as long as that what we're dividing out is not 0. Okay, that just does not work. So we're going to have to factor quite a bit. Okay, so you will be good at this if you can factor well. That's why we did factoring first. When you simplify, make sure to factor everything completely before concluding that it is done. There are no factors that are in common, so make sure you factor them completely. Okay, let's look at an example here. 3y times y plus 7 over y plus 7 times y squared minus 9. Okay. Well, first thing I want to do is factor everything, if there's anything I can do, which I notice I see a difference of squares. Okay. This one right here is a difference of squares, y squared minus 9. So I'm going to go ahead and factor this. I'm going to leave the top the same because it's already factored. And y plus 7, that's going to be y plus 3, y minus 3. Okay, now I'm going to go about canceling things. Do you see any factors that are the same? I do. I see the y plus 7. Nothing else is the same, so our answer is going to be 3y over y plus 3, y minus 3. And that is our answer. Everything is factored completely. We've canceled out any things that are problematic there, anything that's the same on both, so it is in its simplest form. Okay, next one we've got 7x minus 7 over x squared minus 1. Okay, so first thing we need to do is factor everything that we can. So if you look at our numerator, I see there's a greatest common factor. Okay, a 7 goes into both of those. So 7 times x minus 1. And our denominator is a difference of squares. We have x squared minus 1 squared. So we'll factor that as x plus 1, x minus 1. And now you should notice we have something in common on the top and the bottom. Cross those two out, and that gives us a final answer of 7 over x plus 1. There are no more common factors, so that is in fact our final answer. You have to be really careful about making sure we factor everything. Everything, including this GCF of a 7 and including the difference of squares. We need to have all that done. Okay, next, write x squared plus 4x minus 12 over 3x minus 6 in its simplest form. Okay, well, the bottom I see we have a GCF. Okay, a GCF of 3 there. So the denominator will be 3 times x minus 2. Now the numerator, I need numbers that multiply to be negative 12, that add to be 4. Because the a value here, we have just an x squared, so we can do this. So let's see, 1 and negative 12, 2 and negative 6, 3 and negative 4. None of those work, but one of them comes close. Okay, this one right here, if I make that a negative 2 and a positive 6, that'll work. So this should factor as x minus 2, x plus 6. Now, of course, I have a common factor to cancel out, my x minus 2, which leaves us with an x plus 6 on top in the numerator over 3. Okay, and 3 does not go into everything that we've got here. Okay, so I can't factor that anymore. That is it. So sometimes we might have to change the sign of something by factoring out a negative 1. Okay, and a big side note is in this section when we talk about rational expressions, the domain is usually not listed. it's implied that the real numbers that make the denominator 0 are excluded. Okay, so let's talk about that. So here we've got this statement right here that x does not equal y. Okay, so that's saying that right there. Okay, that is not the same, because that would be dividing by 0. Okay, here we're specifically saying that, but other places we might not always. Alright, let's try to factor the top, the numerator. I'm going to make a guess here of x plus y and x plus y. So I've got the x's and the y's, so I say I'm guessing. It's an educated guess. So I'm going to multiply this. Okay, I have x times x gives me an x squared. Y times y gives me a y squared. But then I have x times y and y times x. That would make a 2xy. That's a problem because I actually have a negative 2xy up here. So what I need to change then is my signs. Okay. So x minus y, x minus y. And that is over y minus x. Now what we have in the denominator is very similar to what we have in the numerator, but it's not the same. So what we need to do is multiply the bottom, or factor out a negative 1, I think is how we said it. We'll take a negative 1 out of those two, which makes it an x minus y. Okay, so we have negative 1 times x, negative 1 times a negative y, which makes a positive y and a negative x. So that is, in fact, the same. X minus y, x minus y. Now we have a common factor, which is x minus y over negative 1. Now to make that a little more simple, we could divide the negative 1 into everything. So dividing negative 1 into x gets us a negative x. Negative 1 into y gets us a positive y. Or you could even say that is y minus x. So either of these answers is good. Okay, let's look at it. And of course, remember, I keep saying this, you can pause this. Okay, go back if you need to as you're writing down. Don't rush yourself just because I am. Alright, now these are labeled as now you try. So the good idea would be to pause the video, work through them, and then play it so you can see how I'm going to do it. So I'll give you a second to pause it. Okay, so this is what you should do. We should factor our numerator as x plus 3, x minus 3, and the bottom, I already noticed that I have a 3 minus x, so I'm going to take out a negative 1, make that an x minus 3. These two will cancel out, and so I get x plus 3 over negative 1, which would actually be a negative x minus 3. There we go. Number 2, kind of like that one we had earlier, this one actually will factor. And I'm going to factor this. This is going to be a 6 plus n and a 6 minus n because it's a difference of squares. And numbers that multiply to be negative 30 but add to be negative 1. 1 negative 30, 2 negative 15, 3 negative 10, 5 negative 6. That is actually it. 5 and negative 6. So this will be n plus 5 and n minus 6. Okay, now you see on the bottom I have the 6 minus n, so I'm going to have to change this. So this is going to be a 6. I'm going to put my negative 1 over here. Move it down a little further. Okay, negative 1, 6 plus n, and an n minus 6. N plus 5, n minus 6. Canceling out our factors, We should get n plus 5. Let me put that right over here. N plus 5 over negative 1, 6 plus n. And I'm going to leave that right there. So check your work. If anything's off, now you can figure out how to fix it. Okay, a couple more. Alright, on number 3, that one is going to factor as, well, a 2x and an x. Let's see, a negative 3, a positive 3, and a negative 1. Okay, because that will be 2x squared, 3x minus 2x, be 1x, and then negative 3. The denominator will factor as 1 plus x and 1 minus x. And I see I have something similar, so I'll use my negative 1 concept. So 2x plus 3, x minus 1, that'll be a negative 1, 1 plus x, and x minus 1. So using the negative 1 there switches those two. Those two cancel out, and I get 2x plus 3 over negative 1, 1 plus x. Okay, number 4, I actually see a GCF in here, greatest common factor between terms. So the top, a 2x comes out, which leaves it with an x squared minus 100. The denominator, a 10x, comes out, which leaves us with 10x minus, no, just 10 there. So 10 minus x. There we go. Okay, now our numerator actually factors more. We have 2x, x plus 10, x minus 10, divided by 10x, 10 minus x. Okay, so several things actually will cancel here. But let's first do our negative 1. So we'll make that a negative 10x and an x minus 10. 2x, x plus 10, x minus 10. Alright, so the x minus 10 cancels, as well as the x term we have here. And actually the 2/10 will reduce. So that is negative 1/5. That's what that reduces to. We have an x plus 10 in the numerator, so I will write that like so. Okay, I have negative 1 x plus 10 over 5. Okay, so with simplifying rational expressions, write the numerator and denominator in factored form. Factor completely. Don't forget even a GCF, difference of squares, make sure everything is factored completely. Then divide out common factors. Okay, multiply whatever you have left in the numerator and the denominator, and we will get our final expression. Okay, and undefined rational expressions are the values that make the denominator 0. Alright, that's the end of this portion.